All right, welcome to our second talk for TRiRODS, August 18, 2021. This is Violet White, also an intern this summer, and she worked on the delay server inside the iRODS machinery to make it better. We gave her two different tasks, and she got them done. So take it away, Violet.
I'm Violet. I was working on the asynchronous task framework and the implicit remote features over the summer. Those features hopefully going to make the server more resilient and more scalable. So right now in 4.2, there are three processes that make up iRODS. There's the main process, which spawns everything, the delay server, which handles delay rules, and the agent server that handles all the requests that actually come in from clients. Right now, as it stands, if any of these processes fall over, then there's going to be a problem. You can't really recover from that right now. Luckily, that's going to change. So the asynchronous task framework is meant to run tasks intermittently, specifically the ones that are meant to maintain the server over long runtimes, monitoring and such. And right now, implementation was interesting. We got to the first being the development environment, which was a pretty big obstacle to begin with. I was having a very hard time getting it to even work on a VPS server on the supportive system, but eventually I managed to get it to work once I bothered to spin it up on my own machine. And then there was the threads. I mean, I guess this is probably one of the more common issues for in programming, that threading and concurrency doesn't necessarily work all that well together. In this case, it was caused by the processes spawned by fork and the threads not working together semantically. And I had to solve this by moving it all into the main server loop. And then there was the processes themselves, which refused to get cleaned up. And that I needed to learn more about the POSIX process model in order to do that. So I've got a demo for this. Okay, so it's restarting iRODS. Okay, so as you can see, this is the main process. This is the child agents factory, and this is the delay server. So if we kill the delay, the agent factory and the delay server, they should come back up. And there they are. That happens before every run of the main loop. So any clients that connect to it will cause it to happen immediately if it needs to happen. Okay, so this is how it works. The schedules the tasks. It goes into the socket loop. It watches the processes, restarts them if necessary, and then handles the request. Okay, so right now it suffers from a couple of deficiencies. First is that it's blocking. Any long-running task could bring the entire server to a halt in terms of handling any connections. And anything that is stateful, any plugins, for example, that have any state persisted between requests will produce issues with this when it's restarted. Okay, and in the future, hopefully there will be some monitoring integrated into it, so that we can get more statistics about the usage of a cluster so that you can distribute resources more effectively. In the future, I would also like to fix the threading a problem that caused this in the first place, so that I don't have to be as careful with the blocking. Yeah, okay. So the implicit remote is about introducing new semantics to the delay rules in order to make them scale out over the cluster. I mean, delay rules are already used for long-running tasks. So being able to distribute it across the cluster makes it considerably more useful. In 4.3, you get this sort of architecture where the first resource provider is the first one that gets tasks dispatched to it, and the second one, and then the third one, and so on. And this is hopefully going to be sufficient for to see if this is actually useful for anyone. Anyway, getting this to work was more interesting because I got to work with the networking, more of the networking side of iRODS, the connecting, having to deal with like credentials and users and such. And for example, everything would work auto-magically until the server wasn't trying to process the request itself, but put it on a client server. And this required changing the client connection API to provide proxying. And then after that, there was issues with the tests just not being very reliable. And this took quite a lot of searching because it was very difficult to hard to debug in Docker, essentially. And that's the only way I could run a topology setup like this. And it took a lot of meetings in order to figure out what was going wrong with this. And then it turned out to just be a race condition. It would skip along 2 places because it was being used more often than in more places than I had originally thought about. So right now, the primary caveat that's known with this is that, well, I mean, it's not within this new feature, but it is still there from the delay rules, in that if the rule's partially complete, then the system could be left in an inconsistent state between operations. In the future, hopefully there will be efforts to write a more capable scheduler than round robin, so that clusters of machines can be used more effectively. These are the 2 issues that I worked on, and are there any questions?
Excellent. I will ask you the same question that I asked Gabby a few minutes ago. Outside of the bugs themselves that we encountered and fixed, what was the most surprising thing that you had happen this summer? If the threading and the concurrency wasn't necessarily a surprise, obviously it was a challenge. But what do you feel like you learned the most about?
Well, I feel like I learned how to handle larger projects more effectively, because usually I have a fairly large set of developer tools to help me work in large code bases, like autocomplete and stuff. But with iRODS, I couldn't get that set up because I can't run it on the machine I use for editing, and I can't even compile it there. So
I see. So the development environment itself was a challenge in a way that was surprisingly difficult.
yeah, it wasn't unexpected once I actually looked at the repo though. I mean, it's bundled for more enterprise scale stuff, and the way that it's bundled makes a lot of sense for that. But I've never had to work with that before.
Right. The C++ itself was presumably not a challenge. I feel like you had a handle on that.
Yeah, I've been working with C++ for a very long time. So
yeah. Excellent.
I got a question.
Anybody else got questions? I know that
Has this been tested with something like storage tiering or, some of the other work that heavily leverages the delay queue?
how much did you put in the delay queue, Violet?
I've put hundreds of delay rules in, but and it has worked. But the storage tiering, I can see some issues. I don't know how that stuff works in iRODS all that specifically yet, but I would have to investigate that to know for sure if it's completely compatible. I imagine it probably. I hope it is.
Yeah, I don't think we've plugged it in directly, Jason, but in terms of the volume of things, I don't expect it to be any different. It should work fine, if not just a lot better, because it's not all in one machine.
Yeah, that would be an interesting benchmark to, run Allen's like 100, that was it 100,000, 100 million, moves.
It was more than the computer could do at the time.
Correct.
Right, yeah.
That's the one we want.
Just to see the potential speed ups achieved, yeah.
Yeah. Good point.
Yeah, very good. Anybody else? Good job, Violet. Thank you so much.
Thank you.
I'm glad it all came together, and it seems real nice. All right, thanks a lot.
Thank you.